Hello, I wanted to walk you through doing a limiting reactant problem. Just pretend I'm here with you in the class. So let's do this problem together. There are two different types of problems that I have for you here. There's 6 problems altogether. 3 of them deal with moles, and 3 of them deal with masses. Okay, so let's do one problem together with moles and one problem together with masses, and then you'll have 2 each to practice with the for yourself. Okay. So first off, there is a little more work to do in a limiting reactant problem, but it's just the same work you've been doing. So it's just all that converting between moles and converting between moles and grams. There's no new calculations here. So I just want to make that clear. There are no new calculations here. It's just using the calculations that we've already learned. So a limiting reactant, as hopefully you've either read or heard from Tyler, is the reactant that runs out first in a chemical reaction. So very often when we put chemicals together in a chemical reaction, we're not putting in necessarily exactly the amount that we need to react. So one of them is going to limit the reaction and one of them is going to be in excess. So like Tyler's examples with the hamburgers, right? So if you have 6 buns, but you only have 3 hamburgers, you can only make 3 hamburgers, right? So that's exactly what happens with the chemicals. So we have to figure out, it's a lot easier to just look at some hamburgers and some buns and decide how many hamburgers you can make. It's a little bit more difficult when we're dealing with the chemistry because we have a little bit more math to do, right? But the idea is exactly the same. So just like we've been doing with everything else, it always starts with balanced chemical equation. So first reaction here is that aluminum reacts with hydrogen bromide. So we have to finish and balance the equation. So we're going to have aluminum reacting with hydrogen bromide. I don't know why my lines are moving up on me there. Okay, so the aluminum is a metal. And in hydrogen bromide, the hydrogen acts like the metal, right? It has the positive charge. So the aluminum is going to replace the hydrogen in this reaction, right? So we're going to be left with aluminum bromide. Remember, aluminum has a 3+ charge. Aluminum is 3+, bromine is 1-, right? So that's where I got the 3. Al3, okay? And then hydrogen, don't forget, when it sits by itself, needs to be a diatomic molecule. Okay, so now let's balance this equation. It looks like, because I have the 3 and the 2, right, my closest, my smallest, least common multiple, that's what I'm looking for. My least common multiple is going to be a 6, right? So I'm actually going to need a 6 here in front of the hydrogen bromide, which will give me a 2 here for the aluminum, a 3 for the hydrogen, and that means over here I'll need a 2 for this aluminum. Okay, so now I have a balanced chemical equation. Now I can jump into the actual problem. The problem says if you have 3.22 moles of aluminum, so 3.22 moles of aluminum, and it's going to react with 4.96 moles of hydrogen bromide. 4.96 moles hydrogen bromide. They want to know, first off, which of these is the limiting reactant. So which is going to run out first. And then part C is asking you how many moles of the products are going to form. Okay, so to do that, we need to find out how many moles of the product are going to form, starting with each of the reactants that we were given. Okay, so you should be taking notes here, right, on the steps that we're following. So the first step would be to pick one of your reactants. So since aluminum is written first, I'm just going to pick aluminum and start with aluminum first. Then you're going to determine how many moles of your product can you form given the amount of reactant that you have. So again, I'm just going to pick the first product that I have, AlBr3, and I'm going to find out how many moles of AlBr3 can I form if I have 3.22 moles of aluminum. Okay, so in order to do that, I will first write my equation that I'll use in order to get my mole ratio. So I could see from my balanced chemical equation that for every 2 moles of aluminum I have, I can make 2 moles of aluminum bromide. Okay, now, do I need to actually do the math on this one? Okay, probably not, right? Probably not, because if it's 2 to 2, that means that it's 1 to 1, right? So whatever I have of aluminum, I'm going to have of aluminum bromide. Okay, so what this means is that I'm going to be able to form 3.22 moles of aluminum bromide. Okay, I don't even need to do a conversion for that one. That one's super simple, right? Okay, now, excuse me, let's just scroll down a little bit, give myself a little more room. Okay, now let's see what happens with the hydrogen bromide. Okay, so with the hydrogen bromide, I have from my equation 6 moles of hydrogen bromide, 6 moles of HBr is equal to every 2 moles for every 2 moles of aluminum bromide. So I need 6 moles of HBr for every 2 moles of aluminum bromide that I need to form, that I want to form. So I know that I'm starting with 4.96 moles of hydrogen bromide. That means I want to convert it to moles of aluminum bromide, right? And I want to get rid of moles of hydrogen bromide. So I have 2 moles of aluminum bromide for every 6 moles of hydrogen bromide. And when I do that math, I get 1.65 moles of aluminum bromide. Okay, so here's the first question. Which is the limiting reactant? The amount of aluminum that I have can form 3.2 moles of aluminum bromide. The amount of hydrogen bromide that I form can only form 1.65 moles of aluminum bromide. So once that aluminum bromide is formed, the 1.65 moles, all of my hydrogen bromide is going to be used up. And so that is the limiting reactant, right? The hydrogen bromide is the limiting reactant because it limits the amount of product that I can form, right? It lets me make less product. This is less than that, right? So I can only make 1.65 moles of the aluminum bromide, given the amount of aluminum and hydrogen bromide I have to start with. Okay, so we're on our way. We started with 0 moles of aluminum bromide. We're going to be able to make 1.65 moles, right, leaving us with 1.65 moles. Okay? And I also know that I'm going to use up all 4.96 moles of the hydrogen bromide, leaving me with 0 moles of the hydrogen bromide. Okay, I also know that I started with no moles of hydrogen. So my question now I have left is how much hydrogen am I going to form, right? That's my other product. And I would also like to know, though it doesn't say it specifically in the problem, I would like to know how much of my aluminum I'm going to use and how much I'm going to have left. Okay, so that's the last 2 things that I'm going to have to do. And again, you'll notice at the moment we have not been doing any weird new calculations, nothing different. Okay, I'm going to just zoom out a little bit so we can see the equation while I do the next piece of work. Okay, so it doesn't matter what you do next, but since we're talking about products, why don't we find out how much hydrogen is going to form? So again, I know that hydrogen bromide is my limiting reactant, so that's what I have to start with. So 6 moles of hydrogen bromide is needed for every 3 moles of hydrogen that I want to form. Again, coming from the chemical equation, right? It forms my mole ratio that I need to use. So I know that I'm starting with 4.96 moles of hydrogen bromide. Using my mole ratio, I'm going to make 3 moles of hydrogen for every 6 moles of hydrogen bromide that I have. And when I do that, I find that it's going to make 2.48 moles of hydrogen. Okay, so I'm going to form 2.48 moles of hydrogen, leaving me with, in the end, 2.48 moles of hydrogen. Good. Now, again, this isn't explicitly asked for in the problem, but it's always good to finish it off. And we're going to see then how much aluminum did I actually use up and how much was left. All right, so just keeping this equation up here, I can see for every 2 moles of aluminum, I'm going to need 6 moles of hydrogen bromide. Okay, and then again, I'm just going to scoot up a little bit here, give myself a little room. Okay, so if I started with 4.96 moles of hydrogen bromide, boy, isn't this repetitive, right? And then I know I want to make, or I want to see how much aluminum I'm going to use up, and it's 2 moles of aluminum for every 6 moles of hydrogen bromide. So let's see how much of the aluminum I use up in this equation. No, sorry. Yes, 2 moles for every 6 moles of aluminum. I'm looking at my problem that I did earlier, and I did not write the right mole ratio in. So I'm going to redo my math here right now. Okay, 3.31. So 3.31 moles of aluminum. Okay, what does that mean? So going back up here, wait a second. Oh, sorry, that's right. I made a little math error there. Hang on, not 3 point. It's half that. Sorry, that is not the right answer to that. That should be 1.65, right? 1.65. Okay, so it means that I used up 1.65 moles of the aluminum. So I used 1.65 moles of the aluminum. So I actually don't have 0 moles of aluminum left. I actually have leftover aluminum or excess aluminum, right? And I have, if I do the math, 1.57 moles of aluminum left. Okay, so let's recap. Let me get a different color here. Okay. Let's recap. So what did we do? First thing is we filled in the information we knew from the problem. 3.20 and 4.96 moles of my reactants. Okay, so I knew that from the problem. Actually, very first thing I did was write the equation and balance it, right? Then I filled in what I knew from the problem. Now, it's up to you. It doesn't matter which one you pick. I decided to pick aluminum. So I started with aluminum. And I said, well, if I have this much aluminum, how much aluminum bromide am I going to form? And I know that my ratio was 2 moles of aluminum bromide for every 2 moles of aluminum. So if I have 3.22 moles of aluminum, that means I can make 3.22 moles of aluminum bromide. Okay. Then I had to say how much aluminum bromide could I make if I started with the hydrogen bromide instead. So that was this problem, right? So I know from my equation that I need 6 moles of hydrogen bromide for every 2 moles of aluminum bromide that I want to make. I start with what I'm given in the problem, 4.96 moles of hydrogen bromide. I use my mole ratio, 2 to 6, and I found that I could make 1.65 moles of aluminum bromide. 1.65 moles is less than 3.22. So that means when I run out of hydrogen bromide, the reaction will stop. And it will stop when I have made 1.65 moles of aluminum bromide. Okay, so that is my limiting reactant, and that's the maximum amount of the aluminum bromide that I'm going to be able to make. So that's got filled in here. Okay, that's the amount of aluminum bromide that I can make. Okay, and then what I needed to do was to find out how much of the other product I can form. So knowing that my limiting reactant is HBr, I went back to HBr. I see I need 6 moles of HBr for every 3 moles of hydrogen I want to form. Again, starting with the same value, 4.96 moles of HBr. Here's my mole ratio, right? Mole ratio, 3 moles of hydrogen for every 6 moles of HBr. And that means that I could form 2.48 moles of hydrogen, okay? And so that's where I got that value from. Right? And then just to finish this off, I just wanted to see how much of the aluminum I actually would use up and how much would be left over. So that's this step here. I go back to my equation. I see that I need 2 moles of aluminum for every 6 moles of hydrogen bromide that I want to form. Again, I'm starting with 4.96 moles of hydrogen bromide. Here's my mole ratio, 2 moles of aluminum for every 6 moles of hydrogen bromide, and that tells me I'm going to use up 1.65 moles of aluminum. So here is where that comes into play, right? I've used up 1.65 moles of aluminum. I literally here just did the math. 3.2, right, minus positive 3.2 minus 1.65 leaves me with 1.57 moles of aluminum left. Okay, so I filled in my table completely. I know exactly how much of the products I'm going to form, and I know how much of the reactants I have used up. And this problem is done. And I hope you will see again that there's nothing new here, right? There's no new math, there's no new problems. It's just an application of what we've been doing. It's just that little extra step to say, you know what? I don't have exactly enough of both of my reactants. One of my reactants is going to use up first. It's going to run out, right? So which of these reactants is going to run out, and how does that affect the products that are formed and the other reactants that are left over? Okay, so you have 2 more problems to do, just like this one, just with moles, right? No masses right now, just moles all the time for the next 2 problems. Okay, good luck. Send me an email if you have any questions, and otherwise I will see you guys on Monday. But stop by on Friday. I'm here all day Friday if you have any questions or want to go over anything. Okay, bye.